The abstractions that you design, the behaviors that you implement, and the UI interactions that you build all reflect the business. Together, they constitute the model of the domain. This project can be used as a library, or as an inspiration, or both. Abstractions can hide irrelevant details and use names to reference objects. It emphasizes what an object is or does, rather than how it is represented or how it works. Abstraction and generalization are often used together. Abstracts are generalized through parameterization to provide more excellent utility. On a higher level of abstraction, any information system is responsible for handling the command and, based on the current state, produce new events. Command represents an intent to change the state of the system, and events are representing the state change itself, a fact. The new state is always evolved out of the current state and the current event. Any stateful information system can be designed by using only these two functions and three generic parameters. Decider is a data type that represents the main decision-making algorithm. It represents a pure declaration of a program logic. You may be wondering from where the state is coming and if it is stored somewhere. The decider does not care about storing or fetching the data. It does not produce any side effects of this kind. It represents pure computation. Orchestration of the logic execution will be handled by the outside components which will use the decider to do the computations, and these components will be responsible for fetching and saving the data. In order to illustrate that, we are going to model a state-stored component which will fetch the current state and store new state, and event-sourced component which will fetch the current events and store new events. We are going to name this component an aggregate. This means that by modeling commands, events and state formally in your domain, you will be able to choose the type of the information system, event stored or state stored. A state stored aggregate is fetching the current state by using fetchState method from the state repository. It then delegates the current state and the command to the decider, which will produce new list of events. Finally, the list of events will fold to the new state by using decider evolve function, and the new state will be stored via save function from the state repository. Flagging a computation as suspend in Kotlin enforces a calling context, meaning the compiler can ensure that we can't call the effect from anywhere other than an environment prepared to run suspended effects. And therefore, the runtime has the chance to see the big picture of our program and decide how to run and optimize it. Here, we illustrate fetching the current state, handling the command, and finally storing the new state. It is obvious that decider will decide based on the current state and the command it received. It will publish events as a result, which will fold to the new state that we are going to save into the storage. An event-sourced aggregate is fetching the events by using fetchEvents method from the event repository. It then evolves the state based on the fetched events, and delegates the state and the command to the decider component, which will produce new events. Finally, the events will be stored via save function from the event repository. Here, we illustrate fetching the events, folding the events to the current state, handling the command, and finally storing the new events. It is obvious that decider will decide based on the current state and the command it received. It will publish events as a result, that we are going to store into the event storage. This pattern is known as event sourcing. Event-sourced systems are storing the events in immutable storage by only appending. The current state can always be evolved out of these events, preserving the perfect audit trail of all business decisions you have made in the past. State-stored systems are traditional systems that are only storing the current state by overwriting the previous state in the storage. Being efficient with storage usually requires reopening the design of existing tables as we add new features to our system. Information is far more valuable than the price of the storage these days. Don't throw it away. F-Model is open source. Join us on GitHub. We are rethinking how information systems should be designed and implemented. Till then, happy coding.